Welcome to this video on C++ namespaces. In this session, we're going to explore how namespaces help organize code and avoid naming conflicts, ensuring cleaner and more maintainable projects. Let's dive in. So, what exactly are namespaces? Namespaces provide a way to organize code into logical groups and prevent name conflicts. You can think of a namespace as creating a scope where identifiers, such as the names of types, functions, and variables, can be placed. Namespaces offer key benefits including avoiding naming conflicts between different parts of your code, organizing related code together, and creating a clearer and more maintainable code structure. Here is an example of declaring a namespace. We start with the keyword namespace followed by the namespace name, in this case my namespace. Inside the curly braces, we declare an integer variable named value and assign it the value 100. Then we create a function called printValue that prints the value of the value variable to the console output stream. Now let's explore how to use namespaces in C++. Here we have an example of using namespaces. First, we declare a namespace named math. Inside the math namespace, we declare a constant double variable named pi and assign it the value 3.14159. We also declare a function called add, which takes two integer parameters, a and b, and returns their sum. Now, to access members of the math namespace, we use the scope resolution operator, which is 2 colons. For example, to add 5 and 3 using the add function from the math namespace, we write math scope resolution operator add 5 3. Similarly, to access the pi value, we write math scope resolution operator pi. Let's discuss the using namespace directive in C++. This directive brings all names from a specified namespace into the current scope, allowing you to use those names directly without qualification. In this example, we have a namespace called graphics. Inside the graphics namespace, we have two functions, drawLine and drawCircle. To bring all the names from the graphics namespace into the current scope, we use the using namespace graphics directive. Now we can call the drawLine and drawCircle functions directly, without having to use the graphics scope resolution operator. It's important to be aware of best practices when using namespace directives, especially regarding standard library namespaces. Avoid using namespace standard and header files. Doing so can lead to name conflicts and unexpected behavior. Using directives in global scope can defeat the purpose of namespaces by potentially introducing name conflicts. Instead, prefer explicit qualification with the scope resolution operator, using declarations for specific names, and limited scope using directives. Now let's examine using declarations. Using declarations offer a way to selectively import specific names from a namespace into the current scope, providing more precise control over which names are being used. In this example, we have a namespace called utilities. Inside the utilities namespace, we have two functions, log and format text. To import only the log function from the utilities namespace, we use the using utility scope resolution operator log declaration. Additionally, to import the string type from the standard namespace, we use the using standard scope resolution operator string declaration. Now we can use the log function and the string type directly, but other functions from the utilities namespace still need qualification. There are advantages to using declarations, including more precise control over which names are imported, reducing the risk of name collisions, making code more readable by showing exactly which names are being used, and the ability to limit the scope to a function or block. Using declarations can be limited to specific scopes, such as function scope, block scope, or class scope. Let's explore nested namespaces. Nested namespaces allow you to organize code hierarchically, creating a more structured and manageable code base. Here's the traditional way of defining nested namespaces. We start with the outer namespace company, then nest the project namespace inside it, and finally nest the module namespace inside the project namespace. Inside the module namespace, we define a function called function. In C++ 17 and later, there's a more concise way to define nested namespaces. We can define the entire nested namespace hierarchy in a single line, like this: namespace company scope resolution operator project scope resolution operator module. Then we can define another function called another function inside this nested namespace. When accessing members of nested namespaces, we use the full qualification like this: company scope resolution operator project scope resolution operator module scope resolution operator function. To simplify this, we can use namespace aliases to create shortcuts for long namespace paths. For example, we can create an alias called CPM for the company project module namespace, like this: namespace CPM equals company scope resolution operator project scope resolution operator module. Then we can access the function using CPM scope resolution operator function. Benefits of nesting include hierarchical organization, better code structure, logical grouping of related functionality, and reduced global namespace pollution. Let's recap some best practices for working with namespaces. Use namespaces to organize related code and prevent name conflicts. Prefer using the scope resolution operator for clarity. Use namespace aliases for long namespace paths. Limit using directives to function or block scope. Prefer using declarations over using directives. Avoid using namespace standard and header files. In summary, namespaces help organize code and prevent name conflicts. The scope resolution operator accesses namespace members. Using declarations import specific names. Using directives import all names, so use them with caution. Nested namespaces create hierarchical organization. C++17 introduced simplified nested namespace syntax, and namespace aliases create shortcuts for long namespace paths. Thank you for watching. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.